Welcome back. This should be March 30th, and we are looking at lesson 8.4 in your textbook, talking about graphing now equations, still quadratic equations, this time in vertex form. These are a, in parentheses, x minus h squared plus k, where the vertex is the point h comma k. If you remember those transformations, here is the horizontal shift. So if h is positive, whatever, if h is a positive number, it will look like I'm subtracting and we're moving to the right, h units. If this looks x plus h, that means h was negative and we're moving to the left h units. Remember, that's the tricky part for horizontal translations. If x minus a minus 4, it looks like x plus 4 squared, you are moving to the left 4 places. Talking about functions, they can be even if they are symmetric about the y-axis. A test is if you replace x in the original function with negative x and you get back the function that you started with, it's even. Think of quadratic functions, that basic parabola, that's an even function. If I put in a number, -4, and I square it, that's equal to 4. And if I put in positive 4, whoops, equal to 4. It's positive 16. If I put in a positive 4 and square it, that's also 16. This would be f of negative x, would be what I started with, and that would be the test, algebraic test, for an even function. Odd functions, they're easier to find if you do the algebraic test than they are if you look at the graph. Odd functions, especially, are symmetric about the origin. That means if you rotated them 180 degrees, they would look the same. The algebraic test is if I replace x with negative x, and I get negative that whole function, every sign is opposite of what it was when I started, then it's an odd function. If you look in your book, at example, so that was the core, that's what's in the core concepts. If you look at example number 1, and you're determining whether it's even or odd, and I'm starting with f of x equals 2x, the test is to see what happens to f of negative x. So I replace x and I end up with negative, whoops, I end up with 2 times negative x, and that is negative 2x. So was that even or odd? I substituted in, there's what I started with, negative 2x, that would be negative f of x, and therefore that is an odd function. If I look at part B, x squared minus 2, for that same example, again, so that's f of x, or g of x probably, and they called it g of x, of course. And I want to see what happens, so g of negative x is going to be negative x squared minus 2, and when I simplify, that is x squared minus 2. So did g of negative x look like g of x? Yes, it did. And so this is an even function for example B. Example C gave me h of x equals 2x squared plus x minus 2, and asked to find whether that was odd or even. So again, we start by taking h of negative x and seeing what that looks like. So we have 2 times negative x squared plus a negative x minus 2, and when we simplify, this one's positive, so 2x squared. This is negative minus 2. So h of negative x was not equal to h of x, and it's not equal to negative h of x because that would be negative 2x squared minus x plus 2. So this one is neither odd nor even. And most functions are neither odd nor even. They are their own. If I look at monitoring progress, down at the bottom of that page, looking at number 1, f of x equals 5x, odd or even? Well, how do you tell? F of x equals 5x. F of negative x equals equals 5 times negative x, or negative 5x. Is that negative? I should know that. Yes, it is. So that one is I. If I look at the second one, g of x equals 2 to the x. That's a function that we have not looked at yet. But if you put it in, so g of negative x is 2 to the negative x, which is reciprocal if we remember that. And that's not f of x, it's not g of x, that's not negative g of x. So this one is neither one. Neither one. And the last one that we're looking at is number 3, 2x squared plus 3 was their h of x. H of negative x, in order to test it, is 2 times negative x squared plus 3. Well, negative x squared is 2x squared plus 3, and h of negative x is the same thing as h of x, and so that one is even, an even function. If I look at the next top of the page on 443, we're looking at a new form, vertex form of a parabola, and that's where we started, in vertex form. A, and it looks like x minus h, so just by looking at that equation, I know what the vertex is. If I look at the core concept right at the top, they're highlighting what's happening to that function just with the horizontal translation. So I'm looking at what's happening to that x coordinate. It's a horizontal shift. So when h is greater than 0, that was the red one. The parent function is still in blue, and the green shows what happens when it's shifted to the left. If you're graphing g of x equals 1/2, where am I? X minus 4 squared. And I'm looking at that. What do I know just by looking? I'm comparing it with the graph of f of x equals x squared. Without graphing it, what do we know has happened? I have a leading coefficient of 1/2. Is that a shrink or a stretch? It's a shrink, so it's getting wider. And I'm shifting to the right 4 units. So look at the little graph on the middle of that page where they're showing you what's happened. In the black was the parent function, and in the blue, notice it's wider, and it's been shifted over 4 units on the x-axis. Vertex is still right at at 4,0. 4,0. Monitoring progress, look down at the bottom, 2 x plus 5 squared. What's happening to this one? It's going to be narrower, so a vertical stretch by a factor of 2. And what happens inside? This is where it's moving. Is it going to move to the right 5? That's what it looks like with that plus sign. But remember, it's really x minus, because this is always minus, that negative 5. That's what makes the x plus 5. So this is shifting horizontally to the left 5 units. Put it in your graphing calculator and see. If I'm looking at monitoring progress number 5, what's going to happen to that one? You've looked at negative, so what does that do? Be thinking, x minus 2 squared. So instead of opening up, this parabola opens down. It's not stretched or shrunk, so it will still have the same dimensions as its parent function, and it's shifted to the right 2 places. So it has a vertex at 2, 0. And if you graphed on your calculator, it's upside down, shifted over. If I'm looking at example 3 on the next page, now they've entered the whole shebang. So we have a horizontal shift, we've got a vertical shift, and again, I can tell if it's in vertex form just by looking where that vertex is. That means I also know where the axis of symmetry is. because remember, that's the x-coordinate of the vertex. You know a lot about a parabola if you know its vertex, it'll be the maximum or minimum, and if I know its axis of symmetry, it makes it easy to figure out what it looks like. If I'm looking at example number 3, where we're graphing -2 times x plus 2 squared plus 3, and we're comparing that with its parent function of f of x equals x squared, what do we know happened? Negative means it's reflected, 2 means it's been stretched, so it'll be narrower. This 2 means I'm shifting to the left 2 places, and 3 means I am translating it up 3 units. And they did that for you. There's a little graph. You can see what the parent function was. That's the one in black. In blue is the upside down. That's the one that's been transformed. If I'm looking at transforming the graph, so I'm looking at, consider the function in example 3. That was the one we just did. It's this one. And we want to see what happens when f of x is g of x plus 5. X plus 5. G of x. It's getting late. X plus 5. Not squared. G of x plus 5. And we're plugging it in, so what do I know is going to happen here? G of x plus 5. This is g of x. So wherever I see an x, I'm replacing it with x plus 5. So in this one, I have -2. That stayed the same. X is now x plus 5, so I have x plus 5 plus 2 plus 3. So this is squared. So this is -2 times x plus 7 squared plus 3. So what did it do? It moved it farther to the left, farther to the left. And look at those monitoring progress. These are ones, we'll talk about them. I do want you to graph them in your calculator is fine, so that you get a feel for what's happening. Look at number 6, 3x minus 1 squared plus 6. What do you know is happening to this one? It's got a positive leading coefficient, so it opens up. It's 3 greater than 1, so we know it's narrower than that parent function. It's shifted horizontally to the right 1 unit and vertically up 6 units. All just by looking at that equation, so much you can tell about that parabola. If I look at the next one, which is number 7, I want you to go back with your calculators and look at these. Number 7, h of x equals 1/2 x plus 4 squared minus 2. So for this one, what's happened? That 1/2, it still opens up because it's positive. It's wider because this is less than 1. It's been shifted to the left 4 units, and it's been shifted down 2 units. Just by looking at that, it makes it easier to know what's happening in the graph. And the last one is consider the example in 3 again, which of course I erased, not looking that far ahead. So in 3 we had -2 times x plus 2 squared plus 3. And that function, we were replacing this one with g of x minus 3. So this is that g of x? That was g of x. And now I want to see g of x minus 3. Remember that function notation says wherever I see an x, I'm replacing it with x minus 3. So in this, we have -2, x minus 3 plus 2 squared plus 3. So I have a -2, x minus 1 squared plus 3. So what did this do? Graph and see. And let me know. If I'm looking at, I probably should. I should probably go back and look at that because I was supposed to do plus 3, not here. This was g of x plus 3. So Mrs. Hagee, starting over, here's my equation. x plus 2 squared. It was already plus 3, and we are adding g of x minus 3. G of x minus 3. How about if I read it? So this was the original, and that minus 3 means it's outside that function, so I am fixing this, and when I'm finished, this new function, my new g of x, is x plus 2 squared, no impact there, but no 0 either. I mean a 0 for my term. Excuse me. If I'm looking, goodness gracious, it is very late. If I'm looking at example number 5, the top of page 445, another word problem. The thing to remember about parabolic or quadratic word problems is usually they're asking either how long it takes to hit the ground, what's the maximum or what's the minimum, and those are usually, I'm looking for the vertex or I'm looking for the zeros. That's usually what you're looking for. So look at the word problem. Water fountains are usually designed to give a specific visual effect. For example, the water fountain shown consists of streams of water that are shaped like parabolas. Notice how the streams are designed to land on the underwater spotlights. Write and graph a quadratic function that models the path of a stream of water with a maximum height of 5 feet, represented by a vertical. They tell you everything. So the vertex is going to be 3, 5. The 5 says it was to have a maximum of 5 feet. So that's the vertex. And what are you going to do? And it lands on a spotlight 6 feet away from the water jet, represented by 6, 0. So what are you going to do? They've already told you the vertex, so we already know we've got an f of x. What do I know about I don't know what the a is exactly yet, but I do have a vertex, so x minus 3 squared plus 5. That's from knowing the vertex form of the quadratic equation. So we use the first point to plug in here. And then what we're going to do is we're going to look for, we need to find an x and a y. Remember, f of x can be replaced with y. Well, we just so happen to have an x and a y that we can plug in and see what it looks like. So when we do this, I have replacing the x value with 0. I'm solving for a, is what we want to find. And I have x minus 3, whoops, not x anymore because we know it's 6, squared plus 5. So 0 equals a times 3 squared plus 5. That means negative 5 equals 9a, and that means our a is negative 5/9. So in this equation, I can rewrite this as f of x or y equals, now I know that a is negative 5/9, and I'm going to keep my vertex form, which is x minus 3 squared plus 5. I had a point for the vertex that I put in vertex form, and then we use the x and y coordinates from a second point to find our a. And do you know that is a problem that often appears on SATs? So this is an example to study. And monitoring progress, given that the vertex is 3, 6, what would it be? I would like you to do that. I'll tell you the answer. This is the vertex. And it's still going to be, everything else is going to be the same. And you're doing another one, so for number 9, when you did that, it should have been, see if you get it when you do it, negative 2/3 x minus 3, is that where we were? X minus, oh, of course, because everything was the same. X minus 3 squared plus 6. That's my new one. That's the number, monitoring progress, number 9. And that brings this video lesson to an end. I think this was March 30th, or for March 30th. Homework tonight, it's due, I'm not grading, but it is, I'm checking to see that you upload it so that we know that you're doing your homework, is the exercise 8.4 worksheets, which is sort of a review. Should be easy and not take too long. And then tomorrow, which I think is not April the 1st, but 3/31st, oh, it was very late. all day learning how to do this. Not fun. Well, it's fun, sure. Homework that's due on the 31st is from your textbook. And again, this is listed on my school app, if you go look at that. Problems 1 through 4, 12 through 16 even, 22, 26 through 38 even, 42 through 48 even, 52 through 56 even, and 79 through 82. It looks like a lot more than it is. And again, 45 minutes, or you just see how long it takes you to do. And that wraps up March the 30th, and I'll see you later.